All right. Thank you, fellas, for joining us today on day 3 of our webinar, Unlocking the Full Power of Your CoPilot and Hub. So, in case you missed Tuesday and Wednesday, Cody started off by going over cycle graphs and previous cycle values, how to set alarms, how to look at and summary data, and how to view all that, and just navigate through all the information that the Copilot is showing you, all the different ways to view and zoom in and zoom out and just analyze the data. Today, I'm going to pivot a little bit to what we call the hub. So let me explain what the hub is. So it's kind of a play on words that, that the equipment is called the Copilot. This is called the hub, kind of like a central hub, like air traffic control is where we get that name. And all the hub is nothing more than a server. So, I think going back, I believe Cody said this, that the Copilot has hard drive storage on it, but it's very limited and it's got a time constraint, right? It only holds data for 2 weeks, even if it's not full of storage. It's not designed to hold data long term. So when you purchase a Copilot or a set of Copilots, in 99.9999% of the cases, a hub or the server is a required piece of equipment also. So it's just a server. If you're familiar with what a server rack is, and you can buy that from us. And the main thing we're selling you is the software, or we can give you the specs for the hardware, and then you purchase it yourself. A lot of times the IT department loves to do that. And we give you the software, we sell you the software, and then you install it. So we recommend a hard cabled connection, a Cat5 connection. Mainly because in a production environment, there's going to be lots of noise, a lot of interference, and doing it wirelessly is, these are my words, not technical words, but it's a little sketchy. It can be hit or miss in a shop floor. So we recommend a Cat5 connection, solid hardware connection. All right, so we're going to look at a high level overview of what the hub does. Am I still sharing my screen, Cody?
No, you're not right now.
Yeah, I see that. What do I? Let me get this Chrome tab up. All right, we're gonna go look at the hub right now. I don't know how that stopped sharing. Probably when I hit record. Okay, so here is the dashboard of your hub. So if you look at the navigation on the left over here, where you can see my cursor, these are the main menus of it. So as your Copilot's running, if the job is started, so that you start the machine and then you have to start the software on the Copilot, we call it starting the job. So if the job is running, um, every cycle the data is pushed from the Copilot to the hub. So every cycle is captured, every sensor connected to your Copilot, to your mold, to your machine, it is all being gathered and time stamped and sent through the cable to your hub. Even if you're not viewing the data like live on the Copilot at the shop floor, all that data is being collected. Okay, and I think it does it every cycle. Um, in the past, I think the EDART, the former version of this, it would do it every so many minutes. And I believe now it's every cycle. So the worst thing that can happen is you lose the last cycle. Let's just say lightning strikes your building and burns your Copilot. Everything before that lightning strike is pushed to the server, assuming the server didn't get fried also. That's an extreme example, but things happen. So let's look at this dashboard. So we have machine status. So what you're looking at now is our hub in our headquarters in Traverse City, Michigan. So they're doing a class right now, but it's a Master Motor 1. So they're not using the Copilots, but I asked the guys up there to turn the Copilots on. So this is a snapshot of what's happening right now as we speak in Traverse City. So there's 3 Copilots running. There's one that's connected, but there's 2 that are connected but not running and are down. And then there's one known Copilot that's not connected. So maybe they're doing maintenance on that Copilot. I'm not really sure. Over here on the right, we have, a snapshot of part quality. So imagine yourself on the Monday morning or 8 a.m. daily huddle you have at your shop floor, the production manager or quality and the technicians, engineers meet out on the floor to just, you just got there with your cup of coffee and you're like, okay, what do we need to do? This is the kind of the intent of this. We can see what's running, what's not, and we can see where to go right away. I hate to say this, but what fires to go fight? What to go put out first? Let's stop the bleeding. So over here we can see, so this is a snapshot of everything. So if a machine has an alarm set, it will show up in this. So if you don't have alarms, it doesn't really distinguish good or bad. So of the alarms that are running, we got 43% running good cycles, 43% with no alarms currently, and we have 57% running bad, running reject. So you just saw the status change. So someone must have shut one down. So now there's 2 running and 3 down. So this looks bad, but I want this is a training environment. So we have some alarms set. We don't make a bunch of bad parts up there. Not that we sell. All right, so scrolling on down, when there's another way to look at this data. So we can look, if you follow up here, this is the last hour. So this is the dashboard here is the most cycles. So which CoPilot in the last hour has made the most cycles? So, we got, the Nisei here has made 41 cycles and the Sodic has made 38. So that just gives a snapshot. If you run your production floor, you may have 20, 30 machines here listed. And then we can go up here, we can scroll for the last 8 hours. And you see the numbers change. So that's all the data day in class. We can look at last week. They didn't have a lot of stuff running last week because I didn't ask them to. Let's see about last month. Yeah, so just different ways to sort through the data here. Let's go back to the last hour. So let's say you're like, why is this machine not running? Why has it only made 97 cycles? So let's go find out. We can click the little I button here, and it'll take us to an overview of that job. When we say job, what we're referring to is, here's the scenario. You put in a mold, you did a mold change, you turn on the CoPilot, so you load that job, that mold, and that machine, and you hit start job, and then you start the machine. So that's called a job. So you see right now there's a start time, and looks like it was this morning at almost 10:30. There's no end time because it hasn't ran yet. It hasn't ended yet. Sorry, it's still making production. So this is an open job, and it's still running. Once let's say we do the mold change and stop the machine, then stop the CoPilot, we hit stop job, it'll put a ending time there and date, and it'll wrap that data up in a data packet. Right. So once you hit stop at the machine, that data is no longer visible at the CoPilot. Now it's only visible from the hub. And we're in the hub right now. So in the hub, we can see jobs that are still in run state, or we can see jobs that have ran and completed. So it gives us the machine name, what process we're running, the standard cycle, how much downtime, how much downtime and how much runtime and when it started. And Cody talked about templates yesterday. So review templates are like your digital process setup sheet. It's a way of capturing how the mold should be running, the molded machine. So it tells us what template is running. It also tells us who started the job. Now in our training labs, we pretty much have an admin login. So they're all going to say admin, but you guys who use this in your shop should, I highly recommend you set up user profiles. And then with each of those user profiles, you can set up security. And then you can give each user different permissions. So I hope I don't pick on anybody in the room here, but let's just say you have a quality personnel who comes by and does some check on the CoPilot. They come look at this dashboard, they look at a job, and they grab some of this information. You may give them permission just to only view stuff, but that's probably all they need to do. And if you have let's say an engineer who goes out and develops processes and sets up alarm tolerances and all that, you may give them a bunch of permissions. So that's kind of how that goes. And, when someone makes a change or does something, you should be able to see when it was done and who it was done by. And that can just be a coaching opportunity. Hey, Joe, we saw that you did this last night. I know you did it this way, but let's try to do it this way. Here's just some more breakdown of the information that ran during this run, the reject rate, out of match. So it made a lot of bad parts. Custom fields. This is things like one is like lot number. You could track lot numbers in here. And in this one, these are all the alarms that are sent and which ones had violations. So we had a bunch of these alarms up here and none of them failed, right? They're all in spec. I'm not sure what the error level means there. That's a bit confusing. Don't focus on that. Peak pressure into the cavity. So we had a alarm set on cavity pressure at the end of fill on cavity 2, and we had a bunch of rejects above that high tolerance and a bunch below. Keep in mind, these guys don't even know they're using it. So this just happened in the background. So here's a bar chart of, looks like every cycle maybe was a reject. Hopefully we'll see some today with some green in there. But, if we click on the cycle, we see exactly at, 13:49:33 today, we had an alarm on cycle time. All right. And it was over cycle time. All right. If you have any questions, pop them in that Q&A box and Cody will let me know. Let's go back to the dashboard. So let's go back to today. Today. All right, where were we at? Greatest through our rejects. We looked at that. We can scroll on down, most alarms. And now we have a view of all the different machines that have been running today. Processes. And when we do class, we use a label, the process class. Here's the mold and the alarm count for each of these runs. Processes. Let me talk about that. So when you set up a new mold on a CoPilot, you have machine setup, mold setup. You can have a part setup, and then the last one on the far right is process. The process is where your standard cycle lives, and your alarms and your templates. So you may have a single mold that runs maybe different colors of material. So the alarm values are slightly different based off the color concentrate, or maybe not the best thing to do, but sometimes people run mold that have totally different materials. So you have different settings, different alarms, different templates. All that lives under the process. Okay. Maybe different cavity inserts is another example. So we can go into that this way too. So this is where we were at just a minute ago. How many cycles, custom fields. All right, here's some with some good info. So this would be like, okay, it started at 13:38 was an alarm. And we made some good parts. So you can really dive in and analyze the information, and it gives you down to the time when this happened. So be pretty helpful. Let me go back. Let me go to today again. All right. We were at rejects, alarms. What else can we see here? We got most warnings. Warnings, what those are for. So a reject is we're going to send a 10-volt output out of a dry contact, and we're going to wire that to your sorting device. It could be a reversing conveyor. It could be a part flipper. It could be a robot. It could be a light tree. This is totally a joke. It could be one of those little dog shocking collars just to get someone's attention. That anyway, when we send that 10-volt output, it's to your creativity what you do with the output. So typically it's going to a device that physically throws the part away out of your good parts. Warnings you can set those up and they're inside the alarm. So if your alarm limits the bottom limit is let's say 20 seconds and the high limit is 30 seconds, your alarms will be a little bit tighter than that. And warnings are like suspect. Okay, you're saying, okay, these might be bad. And maybe you don't throw them in the grinder or in the box that is all bad, but you don't want to put it in the green box where all the good parts are. You want to put it in some third location. And that the idea is there, if you wanted to have someone go inspect those and see what condition the parts are in, you could. Typically, warnings will fire before they reject. We scroll on down, now we have a downtime report. So this is really important when you come in the morning, you want to direct your resources to the right location. You can see the downtime for each run. And this eye thing works just like we've been doing, right? Longest run time. So this is not a full-on production monitoring system, but it gives you a quick snapshot of some of the high-level things that production monitoring systems do. Cycle time is a big one for most of us. Most of us are hammered by cycle time, so this gives us a quick view of what jobs were in over cycle the last 8 hours. Let's see, we got some template match stuff. So this is if we have a template. So again, the template is the digital representation of your process, the visual. And we look at that template 3 ways. We look at the machine. Is it set the way it's supposed to be? So all the machine settings, shot size, hold pressure, hold time, cycle time, things like that. We scroll down, but then we have material out of match. So the template looks at that. So material is looking at the effective viscosity, and that's the big one. And I believe it also looks at your recovery time. So if your viscosity changes severely, your recovery time can also sometimes change also. And then the last one down here is the mold. So this would be looking at sensors inside the cavity of the mold. So post gate, cavity pressure sensor, end of cavity pressure sensor. It could be a thermocouple inside the mold also. Again, only if you have a template. All right. Do we have any questions at this point out of anything I've said? Cody, we all good?
Yes, all good. I'm keeping an eye on the questions, and I'll let you know.
All righty.
When it rolls in.
Thank you. So now we're going to go, let's go down this sidebar here. We can look, this is our overall view of everything. We can dive in at a slightly different angle. We can look by machine. So if you know that, this machine, the ARB, I think that's the Arbor, is a trouble machine, and you want to look at that machine and you go, wow, yeah, I suspect that it's not running good. It's down right now. So I better go look at it. You can look at the other machines and, see the status. And it also tells you which mold and which process and cycles and so on and so forth. Start time. All these jobs are still running, so there's no ending time and the downtime. Let's see what the little eye does for us here. Yep, it takes us to the same thing, right? So there's that job overview report. Let's see. So this right here, let me go back. This is, if you click on the 3 dots right there, that just gives us another way to look at this data. Well, we give you multiple options to see the data from different ways. So now we're going to look at it from the mold point of view. So there's a mold called rectangles running. 4 cavity mold. It's ran 156 cycles, and it looks like it started at 9:30 and ended at 11:15. That guy got done with this test really quick. So let's go look at that. Oh, and now we're looking at all the times that rectangles mold has ran. So it ran in the Sumitomo yesterday. And somehow, I guess it ran in 2 machines today, 3 different machines today. Let's go back. Now, let's see. So this is 20 of the records. So what are we doing? We're sorting by mold. So these are all the molds that have ever ran in the Traverse City lab. And we could go on. I don't know how, there's 171 records. So all the research and development, all the things we play around with in Traverse City is loaded in here. For you, it'd make a little more sense because you'd recognize all of the stuff. All right, so let's go focus on reports now.
Jason, we do have a raised hand.
Okay.
And it looks like Andrew raised a hand. Andrew, if you're able to hear me and type in the chat. Yep, we do have a couple questions in the chat. So one of the questions was, what other custom field would I use? I think that's back when you were talking about adding the lot number.
Yeah, that's a good question. That's the one that popped in my head, but I'm writing that down.
Okay, another question was, what would be a different output for warnings?
Okay, good question. So like for example, a reject, you're gonna wire it to the reversing conveyor that just throws your part away, right? The warning could be wired to a light tree. So maybe it's when everything's good, it's green. When you want a warning, that tree goes from green to orange to get your attention. Okay. Or another thing you can do with the warning is a three-way sorting. So imagine your parts fall out of your machine on a reversing conveyor. When it's a reject part, that conveyor reverses and goes backwards out the back of the machine in the red bucket. When it's good or suspect, it goes towards the front of the machine where you're standing. And at the end of that conveyor belt is a flipper chute. So now the warning, if it's a warning, it flips one way. And if it's a good part, it flips the other way. Or you could do that with your end of your robot, right? You could have three things that robot can do. Green means, okay, everything's good. It goes with your good parts. Warning means it goes, okay, it doesn't put it with your good parts, but it puts it in position B, your parts that someone's going to inspect. And if it's a good part, it goes in position C, which is where all your good parts are. Good question.
All right. Before you move on, another question asked, the longest downtime for the past 8 hours only looks at and calculates after a job has been started.
Correct. So yeah, another great question. Typically, when we think of downtime, we're looking at, is this machine cycling? So remember, this is coming from the CoPilot to the hub. So when it says running, it means that the machine is running and the job is running. If you stop the job on the CoPilot and you keep running the machine or don't run the machine, the CoPilot doesn't really know. It does track like that nothing was started there, but it doesn't know what's happening because the co-pilot's not participating in the cycling of the machine, if that makes sense. So really, a lot of let me read into your question a little bit. A lot of people have co-pilots or EDARTs. You can go back in time with this statement. And they have like two molds that have cavity pressure sensors that run in this machine with the technology. And then they have these 5 other molds that don't have sensors. So sometimes we're like, well, I'm not going to turn on the co-pilot if there's no cavity pressure sensors in the mold, right? So they have all the data for the 2 or 3 molds that have sensors, but all the other molds that run there, they don't turn it on, so you have no data. And we would challenge that and go, why wouldn't you turn it on for a mold that doesn't have sensors in it? Right? So if you take that mindset, your co-pilots are going to track all the downtime and runtime for all your molds that run in that machine. And that's just one reason. That's not even the biggest. I mean, all the data that you collect from all the things that the machine is doing is very valuable. So maybe I'm reading into something you didn't intend, but I'm just trying to expand on your question. All the alarms that the machine can set, the co-pilot can do all those plus more. And most machines, if they track data, they might store it for, I don't know, 50 shots, maybe a couple hundred shots, 500 shots. So that is the added benefit. I mean, every cycle mate's going to get pushed to a server, and that data is stored forever. All right, Cody, can you let me know, am I back on the hub now for what you see?
Yes, back on the hub and in reports.
Okay. So this reports feature, here's a great scenario when you might go down to this tab. Let's say that, God forbid, you make a bad part and that part makes it to the customer and they're not happy about it. Maybe you shut down their assembly line. Made a bunch of people cringe right then, maybe. You shut down their assembly line and let's just say it gets even better and well, this is a positive spin. Maybe you can pinpoint when that part was made. If you track maybe you have a timestamp on the part, on a bigger part, and you can know that it was made at a certain time. So let's just say it was made a year ago, a year and a half ago almost. All right. And we know it was this mold right here called, well, it wasn't R2. Yeah, let's just say it was that mold. Okay. And it was started on January 22nd of 2024. And that's the time it was started, and that's the time that it stopped. So here's our report from a year and a half ago. Same type of report we've been looking at. I picked one with no rejects, but I hope you get the point. So now we want to find out why we made that part, right? Because, if you're in automotive, you do a corrective action or whatever you're calling it these days, you want to track it. They want you to guarantee to them it's never going to happen again. So I click on trends over here. So now this looks a lot like the summary graph that Cody showed you Tuesday and Wednesday. Okay, it's almost the same. So purple is downtime. That means the machine wasn't running. And you can add and remove all the things that Cody showed you over here. Okay, and I can also click on my cycle right here on the summary graph, and I can see the value for each of those. And here is the time where my cursor is, if you see my blue pointer there. Now, I can click on this button and go to the next cycle and the next cycle and the next cycle backwards. I can also use there. Sorry.
So speaking of time, another question came in.
Yes, sir.
Is the CoPilot archive data time-based or data capacity-based?
On the CoPilot? So
yes.
On the CoPilot, it has a small amount of storage, and I don't know the number, but it's not big. But the bigger issue, it is time-based. That little solid state hard drive on the CoPilot can be 30% full, and when that data is 2 weeks old, it's gone. So one time I took a CoPilot in my car to a customer and ran some data, took the CoPilot back to my lab, and before 2 weeks, probably the next day, downloaded it on a hub. So it doesn't go away right away, but after 2 weeks, it's gone.
Thank you.
I think that answers your question. So here's a cycle made. Here's the summary graph. And again, you can add machine stuff. If it's green, it's already there. You can add mold items. Just like this part is just like what Cody was showing you. So we already got these added. Okay, and you can remove. Let me remove a few. Yeah. All right, if we scroll down, now I can see that exact cycle. So there's the cycle, January 30th at 9:30 a.m. And that matches the time there. So now, using the arrows on my keyboard, let's get to where some action happened. Let's see over here. Yeah. So if you look right here, the hold time is set really low, half a second, and the pressure is basically zero. That's probably, what machine is this? The Nisei? I think so. Anyway, that's probably minimum hold pressure is probably on zero. So let's go over here to where there's some hold pressure and time. Now we got 5,000 of hold in 6.5 seconds, 6.3 seconds of hold. Now we can see exactly how that cycle went. We can zoom in just like Cody showed you yesterday. Now, maybe we know the whole pressure is supposed to be at 7,000 or 8,000. And wow, as soon as you see this, we go, now I know why that part had sinks in it. I know why it failed. Okay, I can turn on overlays. This is one thing that is different on the CoPilot. You can set and reset the fill volume. Obviously, we're looking at data that's a year and a half old, so we don't need to be doing that now. But we can, if we wanted to analyze the data just a little bit differently, we could turn on overlays. And I'm hitting the arrows on my keyboard, and it's just overlaying cycles. And some of those are look like purge cycles and whatnot. So the main point is there, you can go back in time and look at anything you desire. I'm going to go to a specific date. All right. And I had them run this intentional on purpose last week. So there's the machine, the mold, demo, the process, and how many cycles. And, this, I think we looked at this overview a lot. If you click on these, it just takes you down through the different things. Overview. We looked at overview, but we didn't look at quality. So with the CoPilot and Hub, you can do QC samples. So you can run a high-low study and it'll flag the data. So therefore you go measure the parts and then you can marry the measurements to the specific cycle that made the parts. Quick audit. This is pretty cool. So it shows the initial, so any alarms that were there when the job was started, they'd be listed here. Any changes that happened during the run, like where they went to, and then where they ended up at. So it's hard, this makes it real hard for people to like change alarm bands just because they're stolen away parts. If they do, you can find it, how many alarms and how many notes were added. Remember Cody showed you the notes yesterday? Statistics. So you can, we'll play around with a few here just for fun. Let's do machine values and let's do something simple like cycle time. Whoops. So now it'll give us an upper spec, lower spec, and all the stat stuff to throw in the mini tab and do some cool stuff with it. All right. Let's go up here to trends. All right, this is where we were a minute ago. All right, so I'm going to point out a few things. So for this summary data, one of the cool things about having data like this is you can see trends and you can see events and get a big overview of the data. So let me give you a good example. One time I was at a customer and it was like every 47 shots they made a bad part. Right. And first they didn't know that. They just know at the end of the day they had, a good number of bad parts. So then someone started really paying attention. It's like, man, it happens about once, every 47 cycles. So we looked at the trend data like this, and we could see, let's just say on effective viscosity, we see a bump like this. We could see that cyclical, and it would do it again every 47 cycles. Right. And when you can see it in this format, you can see patterns. So, we go, okay. And then we correlated this 47 cycles to that was every, 30 minutes or so. And so we're like looking around, like what is happening every half an hour? And what was happening was it was feeding and drying material into a funnel on top of a machine that was oversized. And when the material first feeded in there, it was dry. But it took about an hour, 30 minutes or so. Sorry, not an hour. It took us 30 minutes to empty out that hopper. Well, by the time it got to the end of that hopper, the material that was loaded on top was wet. So it makes some bad cycles. They didn't load dry material again. And you can see that clear as day. So I'm going to go to 9:55. Here's my timestamp right there. I'm intentionally going to go to around 9:55 and somewhere right around there. Let me zoom in a little bit. This shows up a little more. So one thing I want to look at here is a trend. So let's look at the effective viscosity. This column right here. What you're going to see is the viscosity trending higher. It started at like 1500 psi a second, and it lands at about almost a little shade above 1900 psi a second. And I'm like, okay, well, what is that? Who cares? Well, look down here at these red dots. If you remember from yesterday, those are alarms. And look at my peak pressure end of cavity 4. At the same time that viscosity was going up, my pressure in the mold was going down. So that would result in what types of defects? That would give us potentially short shots, maybe sakes, maybe voids, dimensional issues, on the small side. Okay, and typically a trend like that is one of two things. It's usually either, and there's no 100% in what we do, but it's usually a material shift. Like one lot of material emptied out right there and someone rolled over, so a new bag, but it's a different lot, or it went from virgin to regrind or regrind to virgin. Or it might be a temperature change. So mold or barrel temp, those things don't happen instantly, they happen over time. So that's a trend, right? There's another thing, and that's more of a step. And I'm going to go to 10 o'clock exactly. Let me put my cursor down here. So if someone does something right at 10 o'clock, look right there. Let's look at hole pressure. So at this cycle, it was at 5,200. And then from one cycle to the other, it goes from 5189 to 5,600. We call that an event. So being that it's hole pressure, someone changed it, right? Someone walked up to the machine and entered in a different value. So you see a big step like that. So that can give you a cue. And the reason we did it, we were getting short shots because the viscosity was high. So we raised the hole pressure. But, it could be, imagine this scenario where people like to push buttons so you can see. Sometimes that can be a mechanical event. Maybe the check ring broke. It wouldn't show up on hole pressure necessarily, but maybe cushion. Maybe cushion was running along just fine. And suddenly it went from, cushion, if the check ring snapped or whatever, it'd go from, quarter inch to 0. You'd see a step like that. All right, let's see if we see any other events. Again, the purple is downtime. While I'm seeing what I'm seeing right here, I want to point it out. Cody touched on it yesterday, but the scaling, if you look at fill time, you're like, oh my God, that's horrible. But let's look at the numbers. The numbers aren't even changing. So that's like the third decimal place that we can't see. All right. So be cautious of looking at what you see. Make sure the numbers tell the same story.
We do have a raised hand. Jason.
Yes, sir. Go ahead.
The question, I'll just read it. Is there a way to be altered by an event such as a change in inputs?
Machine inputs, yes. So typically events, most of the time, they're a setting on the machine that got changed. If that didn't answer your question, please let us know. So events are typically a machine input change, or occasionally they're a machine, like something broke.
Thank you. And Andrew, feel free to expand upon your question in the chat if that didn't quite answer.
Yes, please. Yep. Just let me know, Cody. So here we see the alarms. And Cody talked about the alarms yesterday. So we have an alarm set on end of cavity pressure for cavity 4. So we can see the red dots signify alarms, and it actually gives us the number, right? And this is the high and low limit right there in the light gray colors. And over here they're good, so it's in gray. Let's see. Oh, and let me go to another time, 9:53. No, I got the wrong time there. Anyway, my last one of the other points I wanted to make was the purple is downtime. So you can see that the machine, somebody stopped it at, kind of jumps over. Yeah, so that's downtime. So around 10:25, it went down and started back up at about 10:28. Another one I wanted to look at, 9:52. So let's look at this. Let me scroll up here. So there we have a high cycle time. So it's not, it didn't go, it didn't, the machine didn't stop, but for whatever the cycle time went from 18 and a half seconds approximately to like 36 seconds, right? And what I want you to see is that time. This is what a cycle time interruption does. So maybe it ran out of material. Let's try to figure out why the cycle time went from 18 and a half to 36 seconds. And it didn't actually stop the machine because there's no purple downtime. Right. So let's think of some things that might cause the machine to not stop, but take a longer cycle. Typically, someone changes a setting, but I don't see any steps here. So I know the answer. I'm just trying to lead us to it. So let's look at recovery time. I can get to it. When you're playing with this touchscreen on the laptop versus the CoPilot, it can be a little weird. So if you look at recovery time, there's a spike. So it looks like the recovery time is around 3.7 seconds. And then all of a sudden it went up to 22 seconds. So I wonder what happened. Let's go down here. Let's turn on overlays. Actually, let's go back a few cycles. Yeah, let's turn on overlays. And let's look at stroke. So this is the movement of the screw. So just a little graph and terp here. This is the filling phase as the screw pushes material into the mold. Here we're in the pack and hold. And if I hold it down, this is the volume of material that went in the mold at transfer, 0.96 cubic inches. And then we go to hold, and this is the screw recovering back. It's not taking material out of the mold, but it's loading the barrel. So I got overlays on, and let's just look at the next couple cycles and see what happens. See what happened right here. And there's the cycle. So the material ran out, right? We also have a note right there. See that purple or that kind of yellowish color. So here's the notes that we can view after the job is stopped. So let's see if there's a note about no material. Maybe there is. Oh, okay. Look at this. Material loader was off. So if I click on that, it takes me to that note right when we saw the material run out. So, bad things happen when material runs out. And speaking of the notes, let's look at these. If we click on a note, it takes us to that time. Right. So right there, you made a template. What else we got? Reduce the cooling time. So yeah. What else can I show you folks? I covered most of the stuff I wanted to cover. You guys have had some really good questions today. We hide overlays. So you can isolate, just like Cody showed you yesterday, look at one curve. When you got too much mess going on, sometimes you got so many curves you can't see them. So you pull out the ones you want to see. Another thing we can see here is the input triggers. So we get wired triggers from the machine. Let's look at a template on here. So there's a template. Let's see. Now we have current cycle and then the big capital T, and that's the template value. Let me see if I can show something down here for us. Yeah. Another thing that's an improvement from the EDAR, we see the trigger runs down here. The template shows up. So this is the screw run trigger. This is when the machine is turning the screw, it sends a signal to CoPilot, says, yes, the screw is running here. And we can see there's a slight difference from the template. So something changed. So these tracers down here show the, we call them input, sequence inputs. All right. I think I've covered what I needed to cover today. Let me see if I can figure out how to stop sharing my machine or sharing my screen.
Jason, we do have an additional question that a person would like to answer themselves. Okay. So
I'm looking at it now, I think. What's that?
So they were kind of asking more about the being alerted by the change of inputs when you were talking about the summary graph.
Mm-hmm.
But I can try to bring them off mute and allow them to ask the question, if that's okay.
Sure. Yeah.
Okay.
Let's try that. Yeah, Andrew, we turned off the speak for everybody. Go ahead.
Hello.
Yes, I hear you.
Hello.
Yes, I hear you.
Yep, we can hear you.
Are you there?
I don't think.
Yeah, we're okay. Yeah, we're here. We can hear you. Sorry.
Hello.
All right.
Hello.
Don't think
Good afternoon.
Hello. I don't think it's going to work quite well just now. Go ahead.
Hello.
What?
Andrew, we can hear you. If you want to ask it, go ahead.
Yeah.
Yeah, technology, huh?
Yeah. So Andrew, I'm trying to give you the ability to talk. It's not working very well. If you're able to type your question, please, I appreciate it.
Oh, here we go. Let me try it here, Cody. It's Andrew Feeman.
Yes. We are able to hear you. If you're able to try to restore that, Jason.
Hello.
Yes,
Hello.
sir. We hear you.
Technology. Hello.
I don't think it's gonna work.
Hello.
All right. Let's I put a little poll together and
Hello.
Yes, we can hear you, Andrew.
Holy smokes. What a technical roller coaster. I lost all sound and then started clicking around, and next thing I know, I was wondering what the heck was going on.
You can ask your question now. We hear you.
Oh, phenomenal. Okay. So I totally understand being able to review the summary graph and being able to look for trends. It's one of my favorite features of working through the CoPilot. My question is in regards to the inputs. So things like hold time or hold pressure or like known inputs that a processor would do. Is there a way to be alerted or set, I don't know, maybe a specific warning around it? Now that I'm like, when would I ever use a warning? But I'm wondering, is there a way to be able to be alerted when an input has been modified?
Yeah. So the way we would do that is you would need to put an alarm or a warning around that input, say hold pressure, hold time, for example. And if it goes out of your upper or lower tolerance for hold time and you can do this as a warning or a reject alarm. What we do is when those alarms are violated or warnings are violated, we close a set of dry contacts and we send a 10-volt signal, and that 10-volt signal can go to anything you want it to. A light tree, a reject function.
Yep, all of our pilots, wind up having a reject function where as soon as we alarm out, it goes into its own separate area away from the operator.
Okay.
A lot of times, our question is, we need to go back and look in time, but over the course of a lot of data. And being able to understand that the same way, like when a user changes an alarm limit, we kind of get that notification. It like lets us know. I'm wondering, is there a way to have it let us know, like, hey, an input has been changed?
Well, the way, I think I understand your question a little more. Let me see if I can help out. The only way we do it is with an alarm.
Okay.
Or if you had to put an alarm around said input. So I'm trying to find one here. Let me see. Hold pressure. So if we had an alarm around hold pressure, and when it changed, we would get the notification. All these little red dots are violations of an alarm. I think I really, now I'm reading into your question. Okay. What you can do, can you see, everybody see this screen right here?
Yes.
Okay. Let me show you what I did here. You can export data. So let's say this whole summary graph. Hit the three dots here and we can export. So there's two things to export. Job data means I'm going to take this data and take it in my pocket or email it and put it on somebody else's hub and view it. I don't think that's what you're asking for. So
nope.
What you can do is export to a CSV file and selection type. So let's do selected trends. So if I do all, it'll do all the trends. If I do selected, it'll do the ones that are on the summary graph in the background. Export it. But you guys heard my accent right there. It's going to put that in a CSV file, which can be saved as an Excel file. Can you see the Excel file?
I can't see the Excel file. No, just the export screen. I did use this function today, though.
Okay.
So I understand the process.
Yeah, so then you can highlight, you can sort and do all that for, hold pressure, hold time, whatever. The inputs. Yeah. Yeah.
How do I set up a warning then?
Well, warning would be like, let's say hold time, and your upper and lower limit for hold time is, the lower limit's 4 seconds and the high limit's 6 seconds or 7 seconds. Though, if you violate those, it'll throw the part away. A warning would be something tighter than that, to where if someone changes it, it's not 100% bad, but it might be. So,
so if I have, a plus or minus, like reject window of 2 seconds, I could put my warning at plus or minus 0.5 seconds, which would then at least I would have a data log that, hey man, somebody changed this within its allowed control limits.
Yes, that's a good use of it. Yeah.
Oh, okay. Because I've been trying to rack my head around, like, when would I ever use the warning? Like I'm either, making good parts and sending it down the way. But now as I'm talking through this, it would probably be a good option to utilize. Hey, do I have a processor that's touching buttons that they shouldn't be touching? And then trying to look back at all of this data, it's like it would be a really easy tell to say, oh, we changed some things here, and like these are the inputs that they changed.
Yeah, very good use of that. Typically, the most common way is to just segregate the parts to a third place. But yeah, if you just want to know if it's drifting out a nominal but still in tolerance, that works too.
And so now walk me through how to set up a warning.
Well, we'll have to go to a CoPilot. Luckily, I have one.
You're at your 5-minute warning, Jason, for the webinar.
I know. Let's see if we can get this out or not. Can you guys see this CoPilot running?
I do apologize if this is out of the scope about what we're doing.
You're still sharing the hub report.
Let me stop that. Let me share a CoPilot. Let's pick one. How about this one? So this is, we don't know what we're going to see here. This is a Master Motor 1 class in Traverse City. So how about now?
I can see it.
All right. So here we see a really, really good template not being followed.
Yep.
They don't even know they're using it. How would we set up a warning? Let's see. Now I'm wondering if the CoPilot has warnings. I may have misspoke. I may have been talking about something that was in future development. The EDART had warnings. Yeah, I feel like an idiot now. So all we can do,
there's a lot of moving pieces.
yeah, all we can do, all we have, I'm sorry, I misspoke. All we have is alarms.
Okay.
Interesting. Well, I apologize. Yeah, I think that's being talked about. It's kind of not on the top of the feature list. Yep. Yeah, so here, yeah. Yeah, my bad. I put my foot in my mouth.
No.
Yeah, so one last thing, I'm remoted into the Traverse City lab. We were looking at the hub a minute ago. And you can also just view your copilots live this way. They're all IP based IP address. And as long as you're on the same network as the copilots are, you can remote right into the copilot. Got to be careful with this because you can change things like alarms.
Well, and Jason, someone did comment in the Q&A that Bobby commented through the template, you get warnings.
Yes, but it's not there's no output. It's just a visual, I believe. Tell me if I'm wrong.
No, just wanted to add to the comment there.
Yeah. You're right. There is a template warning feature, but I think it just lets you know in a visual fashion that, hey, it's creeping out a nominal. It's yellow. It's not green anymore. Oh shoot, what was I saying? Oh yeah, when you remote in like this, you got to be careful because you can change some really, really damaging things, and the person standing at the copilot doesn't know. They can't tell, like when I do this, they don't see this. This is kind of like a mirrored view, like alternate universe, if you want to say. It's the same reality, but we're viewing it differently than they are. But if I make changes, then they'll see the change. They're going to be, why am I throwing away parts now? Because I changed their alarms. Well, thank you. Let me see how to get out of here. Stop share. We're right. We got like a minute left. I really appreciate everybody. I found out today that we will get you the recordings of all 3 days of this webinar by the end of next week. Hopefully we get it sooner, but that's what our goal is by the end of next week. Thank you so much for the participation today.
Yes, that was fantastic. Thank you everyone for the questions. That was great.